Hey, welcome back to Class B. Today you will be watching my Algebra PowerPoint on linear functions, arithmetic sequences, scatter plots, and analyzing lines of best fit. Linear functions. When graphed, linear functions appear as a straight line. The function notation for a linear function is f of x equals mx plus b. Each x value is associated with a y value. Therefore, each value in the domain is associated to a value in the range. The domain of a graph may appear as negative infinity, infinity, or it may also appear as 1, 2, 3, 4, 5, if those are the values given to you in order pairs. The range of a graph may appear similar to these, depending on the way it is represented. So right here is an example that we will be using. F of x equals 3x plus 7. As you can see here on the graph, we decided a couple of x values to start out with. We inserted them into the equation, and then we solved for f of x. Notice how when x increases by 1, y increases by 3. Let's solve for the slope. y2 minus y1 divided by x2 minus x1 equals the slope. In this case, the slope would equal 3. So the domain of this graph would be -2, -1, 0, 1, and 2, or negative infinity, positive infinity. The range of this graph would be 1, 4, 7, 10, and 13, or negative infinity, positive infinity. And now we're going to move on to transformations of linear functions. The parent function of a linear function is f of x equals x. So when x equals 1, y equals 1, x equals 2, y equals 2, so on. Transformations can shift the function vertically or horizontally on a graph. When you're moving a function vertically and the value for k is negative, it will shift the function down. But if it's a positive value for k, the function will be shifted up. For a horizontal movement, if it's a negative value, the function will shift right. Here's why. As you can see here, f of x equals x minus h plus k minus h, negative h. So let's say h equals 3. And the negative h would equal negative 3, right? So even though it would look like x minus 3 plus k, you would be moving the function 3 units right. For positive values in horizontal movements, it will shift the function left, using the same logic. So now we are going to cover vertical stretching, vertical compressing, horizontal stretching, and horizontal compressing. When a is greater than 1, the function may be vertically stretched, and when a is less than 1 but greater than 0, it is vertically compressed. For horizontal stretches and compressions, when a is less than 1 but greater than 0, it is stretched horizontally, and when a is greater than 1, the function is horizontally compressed. A sequence is a set of numbers that form a pattern. Take two consecutive terms of a sequence and subtract them in order to find the common difference. A sequence has a range restricted to the terms of the sequence found, and the domain is restricted to natural numbers. The recursive formula can be used to determine the next term in a sequence. The explicit formula can be used to find any term in a sequence. So positive association is when the y values increase as the x values increase. Negative association is when the y values decrease as the x values increase. The line of best fit is a linear function that most closely models the data shown on a scatter plot. Positive correlation is when y values increase as x values increase, and negative correlation is when y values decrease as x values increase. No correlation is when there is no obvious connection between the x and y values, such as x being the shoe size someone has, and y being the number of phone numbers a person has in the contacts app. Analyzing the lines of fit with linear regression. When performing linear regression on a calculator, data is entered and the slope, A, and the y-intercepts, B, are shown. Plugging it into the linear function, it would look like y equals ax plus b, which would be the line of best fit. The correlation efficient shown when doing linear regression would be R, is a number between -1 and 1, revealing the correlation. So 1 would be positive correlation if it's closer to 1, and R being closer to -1 would be negative correlation. When R is the closest to 0, it would mean weak or no correlation. The residual is the difference between the actual y value and the predicted y value. On the residual plot, the closer the residual are to the x-axis show how close the line of best fit fits the data. So if you were looking at a residual plot, you would not really see the correlation, but how close the line of best fit fits the data. Interpolation, extrapolation, and causation. Interpolation is when a model is used to predict a value in the set of values known already. Extrapolation is when a model is used to predict a value outside the known values, and causation is when a change in one variable causes a change in another variable, like studying longer may allow a student to perform higher on a test. That would have causation. That just about wraps it all up. So let's review. We covered linear functions, domain and range, transformations, vertical shifts, horizontal shifts, stretching, and compressing. We did not cover reflections in this episode. We covered arithmetic sequences with explicit and recursive formulas, scatter plots with association, correlation, lines of best fit, causation, interpolation and extrapolation, and residuals. I hope that this helps you, whether you're just reviewing for fun or studying for a test. I hope I'll see you next time. Bye!